Hi, my name is Klins, and today we're going to talk about the conservation of angular momentum using this office chair. And these 10-pound weights, this measuring tape, and a timer. Now, the reason we use the weights is to make the angular momentum value bigger, so it's easier to measure. Now, to measure angular momentum, we need these three variables: the mass, the velocity, and the radius. Now, in this experiment, I'll be sitting down on this chair, and I'll rotate. There's two different radii. One in which I'm holding the weights in my hands, and in one situation, I'll hold my arm up like this, and the center of rotation, which is the center of my chest, from the distance from the center of rotation, which is in the middle of my chest, to my palm, approximately where I'll hold the weight, is the radius. I call this r sub long. And the second situation, I'll hold my hand up like this, where the radius is smaller. And so I'll be measuring from the center of rotation, which is the center of my chest, to approximately where I'll hold the weight. So I've already measured those. For the long one, it's 0.825 meters. For the short one, it's 0.216 meters. Great. Now, how do we measure velocity? So the way I do it is I measure the time in which I rotate 90 degrees. So I'll start from here with approximately the same velocity. And I'll start measuring time when I face this direction. And I'll end when I face this direction. Now this is approximately 90 degrees. And so I'll divide 90 degrees by that time I measured, and that'll give me a approximate velocity value of degrees per second. So here they are. For the short radius, I got 99 degrees per second. For the longer radius, I got 32 degrees per second. These are the time values I measured. You probably can't see them because of the green ink, but yeah, to save time, I've already done the experiment. Now, the conservation of momentum should happen in one system. However, because this chair has so much friction, I can't possibly maintain the same speed forever. It stops very easily. So to try to mimic a system where energy is conserved, not lost to friction, I would try to start with the same velocity to try to mimic the initial conditions of the system. So it should be about the same as one system. So I've already calculated the values for and here's the equation for conservation. Let's see if the left side is equal to the right side. So the right side stands for the angular momentum when I'm extending my arm, and the left side stands for when I'm not. So the left side gives out 21.48, and the right side gives out 26.42. Now, I know there's about like 5 something difference. But it's understandable because this is real life, and these are not particularly scientific measurements. They're not that accurate. So there's some errors, but we can about say that angular momentum is conserved in this process. So is angular momentum conserved in a closed system? It is. Thank you.